are to have your assignment this week, yes? And I think I will give it to you tomorrow. When did I say I will give it to you? Did I say anything about that?
Only week 11.
Yeah, so I am due to give you guys the assignment this week. So it could be tomorrow. So during the tutorial, you guys might need to complete, not complete, like, I mean, I'll give you a few days to complete it. Let me just check. Yeah, there are 7 questions altogether. Chapter 2, Chapter 3, Chapter 4, and Chapter 5. And correct me if I'm not correct. The the coverage of the syllabus, we are in our final chapter, is it? We finished the chapter 6. Am I correct? Yes.
Sorry, what again?
I mean, we finished chapter 6, right?
Oh yeah.
Okay, so today we're going to start with chapter 7. And it's not much. I believe this week and next week we should finish the syllabus. Yeah, completely finished. So we have plenty of time to do revision, depending on how you guys would want it to be. Um, I guess because there are less students in this class, there's only 3 of you. So therefore, mm, I didn't get much question from you guys as well. So that's why our progress is very fast. I'm a bit concerned as well why I managed to complete very fast. Is it because I don't know. During the lectures, I try to cover as much as I can. Was it? Can't remember. Why is it that we are on chapter 7, the final chapter already? Let me just
So
double.
we are ahead of
Huh?
the expected.
Yeah, we are very much ahead. Let me double
Oh,
check. Yeah, confirm. Yeah, we finished chapter 6. Is it? Did I skip any chapters?
I
I
think
don't think.
no.
Yeah, I don't think I'm that kind of person to skip any chapters. Let me just open the form B while waiting for Farah. Farah is not here yet. Let me check the form B and let me share with you guys what is the form B about. Mm, So you can see this is form B. Can you see it? Mhm. And
Like
we've covered most of it, I think. Yeah, I've talked to you about estimation, confidence interval. Yeah, and you see, we are about to start with this regression and correlation. It should be in week 13, but we are in week 11. I've already covered with you guys the hypothesis testing and also, oh, not so bad, La Classy. Week 12, it's also covering the regression and correlation. Yeah, so we're not so bad. We're just early by 1 week. Yeah, so that should be okay. Shouldn't be a problem. Yeah. So let's start. So I'm correct then. But the thing is, in chapter 7, I only have a few slides, not much. And maybe because it's new, I'll go a bit slower in this topic. So is Farah here already? Not yet, yeah. We present chapter. Okay. Do you know where Farrell is?
No, I don't know. Maybe still sleeping.
Hmm. I hope he'll join us because this is totally a new topic. I'm not sure. Have you guys learned this before? I think you have, yeah. It's called regression and correlation. Um, should be. So let's just wait just 3 more minutes. I'll start exactly at 9, 10 minutes. Okay. Okay. Hello. Hello again. It's 9, 10 minutes already. Sarah is still not here, but I cannot wait any longer. Um, so shall we start?
Okay.
Yeah. Anyway, it will be recorded, so I bet he can refer to the recorded ones. Anyhow, so let me just record it. You can hear me well, is it?
Ah, yeah. Very clear.
Okay. So let's start. I hope everybody is ready. Good morning, everyone. Today's date is the 29th of 29th of March 2021. We are on week 11. I was trying to figure out why my PC doesn't, show the full screen. That's why my mouse was like flying around trying to click on the button that would make it whole screen, but I couldn't find my pointer, my arrow for the mouse. Apparently it's lagging. Yeah. So this is what we're going to do today, class. The final chapter in BAMS 1613, Probability and Statistics. The topic is called regression and correlation. It's the same as what has been covered, as what the students in the diploma program did cover, but I see the name for their topic on this is called correlation and regression. But for your group, it's called regression and correlation. I was trying to figure out why, and I think I guessed it already. I think it's because we're going to do regression first, then we're going to do the correlation part. Because in this chapter 7, there are two parts. One is the regression area, and the other is the correlation. Now, both actually is the same purpose of learning it is to allow us to be able um, to see what is the relationship between two variables. So in this case, we're only going to look at two variables. Yeah. Um, in actuality, there are many other variables that you can compare with, but of course, using a different statistical tools. Yeah. But this regression and correlation is only concerning with comparison or finding the relationship between two variables. And this is a popular statistical tool. If you have been reading, magazines, business magazines, you'll see that sometimes the report would quote on the value of the correlation or the equation of the regression analysis. And if I'm not mistaken, the name regression, the topic on regression, was covered during high school. Yeah, if you can still remember, it's creating an equation which is similar to a linear equation, a straight line equation. So perhaps when we start discussing about it, you'll be able to recall it much better. Okay, so what is it about? Yeah. Now, there are several important terms that you must understand in this chapter. The first one is correlation. Then we're going to look at what is the meaning of regression. And then I think you all know what is independent variable and what is dependent variable. Now, the first one, correlation, what we're going to do here is we're going to check out the strength between two variables. We're going to measure what is the strength of relationship between the two variables, whether they are, positive relationship or a negative relationship. That's what we want to check out. And what does it mean by positive relationship? And what does it mean by negative relationship? Yeah. So just make sure that you understand that correlation is to measure the strength of relationship between two variables. What is the level of relationship it has. So we're going to look at a table later that define all the strength of relationship that could exist between two variables. The next one is regression. This is also to identify relationship between two variables. But what we're going to do here is we're going to create a mathematical equation. And there is a formula that we're going to use. Yeah. And I bet when you look at the formula, you'll remember that you've done it before. Yeah. And since it's open book, yeah, no need to memorize the formula. You can refer to your notes for it. And for this subject, you only have 7 chapters, so it's not difficult for you to find where it is located, provided you have made sure that your notes are properly arranged and easy for you to access. Um, yeah, I got to know yesterday, only yesterday, because we received a memo that starting next semester, we're going to have what it is called as a hybrid um, learning, meaning um, students can choose whether they want to go back to the campus or they want to still stay online. So classes are to be conducted depending on the group lah, yeah, whether it will be the lectures conducted online or face to face or both, yeah, because it's like ongoing classes and yet students who cannot come back, they would do it online. But to my understanding, next semester the tutorial will be face to face. All tutorials will be face to face. But then all that is pending for, how do you say, pending for next memo lah. That was what was received. So thinking about it is already giving me a headache because imagine if you have to do lecture and then tutorial, which one is online, which one is face to face. Even handling 5 subjects this semester is already confused me. So many things to do. Anyhow, um, why I was talking about that is because for next semester, it may still be online exam assessment. Um, Next semester, I'm talking about next semester. This semester, of course, it will still be online exam assessment, but I heard that next semester it would still be online final exam assessment. Yeah. So I was thinking that perhaps for the next semester in June, we will all be able to go back to the campus already, and exam will be conducted as before COVID. But that's the latest news lah, just to inform everyone. Yeah, so the reason why I say that is because about the formulas, right? So it's still open book and next semester would still be the same. But this semester, of course, it's open book. So those are the 2 important terms in this chapter. You also have independent variable x. What does it mean? It is the value that we use for prediction. Another name for it is called explanatory variable. It's independent variable. It's the x. It's a value that based on the variable we cannot control it, like the weather outside. I mean, the weather we cannot control. Yeah, and that is considered as independent variable. Yeah, we'll look at some examples later on, but another name for it is called explanatory variable. I've never seen in the exam question using this term, but it would be good to remember that the independent variable is the value used for prediction. So in a way, it is the input. Yeah, we use um, the input as the value that we will put into the function. Yeah. So if you remember the function that you have learned in discrete mathematics, uh, we have the input. So same thing here, independent variable x is the input, yeah, value used for prediction. Then we have the dependent variable, just like what the name is. Dependent variable is referring to the variable to be predicted or to be explained. Yeah. And of course, just as what the name refers, dependent variable is that it depends on what is the value of the x. We will only be able to get the value of the y, the dependent variable, which is dependable totally from what is the x value. Yeah. So these are the four important terms in this chapter. What is correlation? We want to measure the strength between two variables. I will show you a table concerning it. Then we have regression. This is to check out the relationship between the two variables by using a mathematical equation, of which, like I said, it's a very simple equation. You have seen it before many times, apparently. And then we have the independent variable and the dependent variable. Okay. Any questions so far, class?
No.
Kelvin, are you here? I didn't get the response from Kelvin. I hope you are here, Kelvin.
Hello, Zach.
Yeah, now I can hear you, Kelvin. All right. So moving on to the first thing first is example one. A simple example to show you about two variables. So let's say there is a study on relationship, meaning we want to measure the relationship between the sales of ice cream and temperature. So if you look at these two items, sales of ice cream and temperatures, these are the two variables. But which one is the independent variables and which one is the dependent? And if you look at it, sales of ice cream and temperatures, I'm referring to the weather outside. So if it's about the refrigerator, then of course we can control. But when we talk about the temperatures outside, therefore, the two variables here, cells of ice cream and temperatures, therefore the independent variable x would be the temperatures and the dependent variable is the y, the sales of ice cream. Okay, and it's very important to determine which one is the independent variable and which one is the dependent variable in the question. But just to let you guys know, normally if you are given a table, let me just draw a small table, and the data are given to you. Of course, the table would have many columns with all the values. Now, the first value here would normally be the x. That means it will be the independent variable, and the below one would be the y, the dependent variable. So this is the format of the question in the exam or in the test. I mean, you guys will not have a test anymore. You only have your assignment left, which is not covering this chapter, by the way. But this question definitely will come out in your final exam. Yeah. So always remember when a table is given to you and you are required to solve it, remember that the first row is always the independent variable, and the second row is referring to the dependent variable. So here, based on the dependent variable and independent variable, we will use a scatter diagram to present them graphically. Yeah, and to use a scatter diagram to represent the relationship of the two variables graphically, of course, we are looking at combination of coordinates of x and y. Mhm. Right there currently, out of space. That means we're going to look at a group of combination of x and y, and that would be your coordinate, and you would plot it on the graph. And we call that graph as a scatter diagram. So you'll have many coordinates of x and y, of which you will plot it on the graph of x-axis and the y-axis. Yeah, and of course, when you draw a scatter diagram, as I mentioned just now, it is a plot. Yeah, it is a plot of paired observations, x and y. Yeah, and what we do is from the scatter diagram, you should be able to identify the relationship between dependent variable y and independent variable x. Yeah, um, meaning the two variables x and y, we call it as a positive relationship is when the value of x increases, the y also increases. That means um, as you go and plot the scatter diagram, as your x value increases, the value of y would also increase. So this can be shown, for instance, like this. Yeah, let's say you have first x and y, the coordinates is shown by here, then the other one is up here. So what you see here, class, it shows a positive relationship because look here, the x value is here and the next value of x is up here. So as the value of x increase, this is the first x, you can see it's increasing, right? Therefore the y, you can see it correspond to the y here, it's also increasing. So this is what we call as a positive relationship, because if you connect the points, yeah, say I use a blue line here to connect the points, it shows a positive relationship. However, yeah, um, if we have another graph, oops, not very nice. And then we have this x value here, the other x go here. You can see here, in terms of what I have here, you can see the value of x is small and it's increasing. But look here, the y, it goes down. You notice that? The x increase, but the y goes down. So this is actually showing to us a negative relationship. You see, it goes this way, shown by this blue line. So you see the difference, yeah? Positive relationship is when your x increase, your y also increase. Negative relationship is that as your x increase, your y decrease. So that's what we're going to check it out. Of course, it's very easy to determine that. I mean, by just looking at the graph, you can tell whether it's a positive relationship or a negative relationship. It is true. Yeah, by just plotting it on scatter diagram, you'll be able to generalize it. But of course, we need accurate measurement, and that is why we have to do the regression and correlation analysis. Now, not only that, we also have to consider linear or non-linear. What does it mean? Linear is referring to the relationship between two variables, which can be represented, like a straight line. This is in the sense that, of course, we all know any two variables, it's very impossible for the relationship to be a linear relationship, a straight line relationship. So we assume that it can be represented as a straight line. We also have non-linear. It means relationship can be represented as a curve. But of course, in our discussion today, we're going to focus on the linear. The non-linear, where the relationship can be represented as a curve, is in a sense what you have covered during high school, if you remember, on the topic of differentiation. Yeah, and that is basically looking at um, a curve or a non-linear kind of relationship. Yeah, but of course here we focus on the linear, whereby we assume or we can represent it as a straight line. Yeah. So, any question based on these slides? Any question, anybody?
No.
Okay, it is understood, yeah? I hope it is. I'm cleaning my screen. It's a bit dusty. Okay, let's move on. So this is a scatter diagram, an example of a scatter diagram, and it's the weekly maintenance cost and age of machine. Yeah, so that's the title. The chart title is up here, and the x-axis is referring to the age of machines in months. Again, age of machine is something that is not uh, uncontrolled by us. You cannot control age, can you? Yeah, age will keep on increase, but the maintenance cost is dependent. So that's why age of machine is considered as independent variable, and maintenance cost is considered as dependent variable. Now, what you see in this scatter diagram, the data is available in your notes. You can see starting from 1, 0, yeah, the value of the next one, yeah, it goes to this value. And this is basically showing us somewhat like a straight line, yeah. So I've drawn a straight line here in red, which we can represent it, even though it doesn't represent exactly a straight line, but we are making sure that it's equally divided, that half of it, like you see here, 1, 2, 3, 4, 5, 5 of the points is below, and the above is 1, 2, 3, 4, 5, 6 points is above. So almost half divided equally, and therefore um, we can actually have this line. But of course, when we do this, it's very, um, how do you say, it's not accurate, because we only draw the line according to what is best fit, we call it. So it's not accurate, because it could be that this line can be slanted a bit, pointing upwards. The curve or the gradient is much more higher, but therefore, that is why by doing this, it is considered less accurate. And that's why we need to calculate the mathematical equation that would represent the um, the relationship between the two variables. So for that, we're going to create the equation now. We call it as a linear regression. And this method, regression method, is allowing us to get a mathematical equation that would describe the relationship between the two variables. Yeah. And from the equation that we created, the mathematical equation that we created, it is hoped to be used for comparison. Yeah. Or in fact, we can use it for estimation purposes. Yeah. And this method, linear regression method, is basically called the least squares method. Some reference book they use this least squares method. So if you read, I mean like if you come across to the word least squares method, it means the same thing as finding the linear regression. Okay, so this is a standard method, mind you, a standard technique. Why does it? Why is it called as a standard technique? Is because it's internationally known. Yeah, this method is widely used in many areas. So what we're going to look at is called the simple linear regression, and the simplest form of linear relationship between two variables is what you have, I think you have come across to it. It's y equals to a plus bx. Now this can be similarized to what you have learned in high school. Y equals to mx plus c, you remember? Of which I can rewrite it to become c plus mx. Do you see that? That means the a is equal to c, the b is the gradient, whereas the x is of course the x. So this time you have to adjust yourself that whenever you see the a, it is where it cuts the y-axis. Because remember, if you recall back, when you have y equals to mx plus c, the c, if you remember, is the value where it cuts the y-axis, remember? And the m is the gradient, which is the b. So therefore now you should know that the b is the gradient and the a here is where it cuts the y-axis.
So it's the same formula.
It's the same, but of course here we are using this formula, y equals to a plus bx. So remember, the b is the gradient, the a is where it cuts the y-axis. Okay, Noah?
Okay.
Okay, so as what I was mentioning, y is the dependent variable. The a is interception of the line at y-axis. Yeah, and the b is the gradient. Yeah, regression coefficient also it is called, or slope or gradient of the line. That's our gradient. And of course, the x is the independent variable. So what we're doing here is basically in reference to what you have learned in high school. Yeah, and we develop more into it. And if I'm not mistaken, when I was teaching in high school last time, I remember sharing this to a class. I don't know whether it's covered in ed maths or in just mathematics, but I remember, yeah, it is in the syllabus in high school. Okay, so from here, um, I hope you understand the linear regression. So from here, we can start creating the mathematical equation. You can see that linear regression is a method to get a mathematical equation. How do we do that? Is by using these two formulas. So this is the least square method. First, you need to find the value of b, which you need to calculate all this, and then you can find the a. Because look at the formula for a. The value of b is part of the formula for a. So that means you must get the value of b first, then you can get the value of a. Yeah, I hope that is understood. Yeah, and you can see in example 2, this is an example. You can see the months. I only have a short example here. I mean, um, a shorter, that is not the correct word, less value for us to calculate because I want to introduce to you about the least square method. So we only have months from 1 to 5 months and the output and the cost. So like I mentioned, the top one, first row, the output is your X and the cost is your Y. Okay, so in order to solve this, what you need to do, there are 5 data or 5 combination of X and Y. So you see all this. And the thing is, from the formula, you know that you need to find the multiplication of X and Y, uh, sum it up. Then you also need to get summation of X, sum all the X. That means all the X here you have to add, sum of Y, add all of the Y. And then you also need to find the X squared and then X, summation of the X and power 2. So take note the difference between these two things. Yeah, this one you need to power 2 the X, and then this one, the summation of X that you obtain here, you just power 2 it. Yeah, so same thing with finding A, you need to find summation Y, divide by N, and then put the value of B that you obtain, and then multiply with summation X over N. And that, of course, when you put it into the table and you calculate it, you can see X and Y are the given information, right? You must show this table as part of your answer, and you must calculate the total of X. So if you add all this, you get the value of 100, and then total the value of Y, you add all this, you get 400, and then you find XY, multiply, meaning 20 times 82, you get the value, and 16 times 70 is 1120. Calculate each one of them and total it. So that's why you get summation of XY 8104. And you do the same thing for X squared, yeah, and you get 2040. So therefore from here, you put it into the formula. So take note, yeah. Another important thing is the 5. Why is it the n is equal to 5? Is because you have xy, combination of xy, you have 1, 2, 3, 4, and 5. And that is why your n is equal to 5. So to find the n is not difficult. You just need to check out how many rows of the combination of x and y that exists, and that is your n. So you put the values into the formula as what you see here. Yeah. And what is the answer for B? Have you calculated it?
No.
Uh, What is the value? Oh, Farah, I see you are here already. Why were you late, Farah? Farah? Oh, why did you sleep very late, Farah? Oh, oh yeah, you did write earlier. I didn't read the chat. Oh, you overslept. But why did you sleep at 5 a.m.? Are you working, Farah? Or you cannot sleep? Yeah, that's my problem. Oh, I see, Simon. Yeah. My problem is, whenever I sleep late, sometimes I do sleep late. And then, when you sleep late, you wish to wake up like today's our class is at 9. So I always want to, wake up at 8 a.m. at least because I sleep late, right? But it's like clockwise for me. Exactly at 6:30, I would be awake. I don't know. Getting old, I guess. Yeah. Oh, thank you, Noel. Yes, your answer is correct. Yeah. So when you calculate it, your B is 2.6 and your A is 28. So this is how you calculate them. Yeah. And of course, once you get the B and the A, you can see the B 2.6, you put it into the A and you get the answer A as 28. You also need to write this class. You see the one in yellow? It's important for you to write that. So you need to write the regression line is therefore y estimate. You see the hat on the y. It is to validate that it is an estimation uh, of the regression line, which is equal to 28 plus 2.6x. So you see here, this is your A, 28. This is your B, 2.6. So this is your gradient. 2.6 is your gradient, yeah, your M. And 28 is the value where it cuts the y-axis, the c-intercept, if you remember what you've learned during high school. And isn't it easy to create the equation, class? Yes or no?
Okay.
Is it? It's okay, right? It's not that difficult to calculate. And some more, I think you can recall to what you've learned during high school. Yeah. So this is
So
another
the
example.
Y,
Mhm. Sorry.
the Y must have the hat on top.
Yes, yes. By right, you should have it. But the diploma students, I tell them if they didn't write the hat, I'm okay. I'm not very particular, but for degree students, I am particular. Yeah. So make sure you write the Y with the hat. Um, yeah, by right you should write it. But myself, I sometimes forget it also, writing the hat. But it is advisable to write it. Yeah? It's the proper way of writing it. Yeah. So I hope that is clear. Now, any other question on this? That was a good question, Noel. The rest, any other question? Kelvin, any question from you?
No.
No. And Sarah, so far okay? Can catch up? Okay. So this is the example, the next example. This example is good so that you'll know how the question is going to be like. Yeah. So you see, what we're going to do here is we're going to use the regression line. Sorry. First, the question asks you to find the least square regression line. Yeah, so that means you need to create the equation based on the data. It's a bit lengthy, yeah, because we have 10 n, 1, 2 until 10. You see, our n is 10 here, so it's a bit lengthy to calculate. And then you see, the next part is to do the prediction. And then the next part is ask you to comment on the accuracy of your estimate. So this is what we're going to do next after our break. Yeah. So we'll start around 5 minutes later on after our break. Okay.
Okay.
All right. See you guys. 5 minutes. Hello. Hi. Are you all here?
Oh yeah.
Okay. So let's continue with example 3. And as you can see, like I said, there are n data altogether. N equals to 10, that is. Yeah. So from here also, once we have already obtained the least square regression line, we are to do a prediction of the maintenance cost, whereby we're looking at 40 months old. That means that's the age, that's your X. Yeah. And then comment on the accuracy of your estimate. So I think this is the part that is important, the comment part. Yeah. So first, we need to find the least square regression line. So this formula is the one that you have to do first, meaning I hope you did calculate the total of the summation of xy, which is it given in your notes? The summation of xy is 97,650. Is it given?
Well,
Is it there? Well, anyhow, I hope you know how to get the summation xy. It's the multiplication of each of the combination of the question here. That means this is your x, this is your y. You need to calculate it, multiply it for each one, and then total it. And same thing for summation of x, total all the x, total all the y. And also you need to calculate the x squared and also the y squared. Y squared no need, only the x squared, this one. So if you put it, if you have calculated it and you put all the values into the formula, this is how, this is the values all in place already. And when you calculate it, you should get the answer is 2.8, approximately lah, 2.8. But you notice or not, when I use it in the calculation of the value of A, it is 2.803. I'm using the full values into the formula. Yeah, 2.803 into the formula. So what you see here is therefore 212.91. Yeah. What I'm trying to point out is, even though approximately it's written as 2.8, when you calculate the value of A, use the B up to 3 or 4 decimal places. Yeah, so that you will not lose any accuracy in the value of A. So you see our A is 212.91. But class, if let's say you use 2.8 only into the formula, I would not penalize you so much as well. I mean, it would be best if you use up to 3 or 4 decimal places into the calculation. Yeah, so this is the values of A and B, and you can put it into the least square regression line of maintenance cost on age. And this is the equation, the mathematical equation. And you see or not, class, whenever we write the least square regression line of, do you notice that this is the value? No, not value. This is the statement, maintenance cost is your Y, on age is your X. That means the one that we're doing here is the least square regression line of Y on X. Do you understand my meaning? Y on X. The least square regression line of maintenance cost on age. This is the equation. Yeah. Just to share with everyone, some materials, reference book, there would be a different calculation, the least square regression line of X on Y. So here we're doing Y on X, but in actuality, we also have X on Y. But our syllabus, we do not cover it. We only cover one type, which is y on x. Yeah. So this is the complete writing of it. Yeah. And then we already obtained the mathematical equation. And therefore, by using the regression line, we want to predict, yeah, when the age is 40 months old. Comment on the accuracy of your result. So that means when we have 40 months old, it means that your x is equal to 40. Yeah. So you just need to replace it in the regression line. So y equals to 212.91 plus 2.803 times it for t. Yeah. So when you calculate it, you get this value. So this is the maintenance cost that is expected when your machine is 40 months old. So since the question also asks you to comment, we call it as interpolation method or interpolation estimate, which in this case, interpolation means the estimate is more accurate and more reliable because the value of x that is used, whereby our x is 40, it falls within the observed range of 5 to 60. So it's more reliable. If your x is equal to 80, 80, yeah, then we call it as extrapolation. When it's extrapolation, it is less accurate and not reliable because it's outside the observed range. Now, where do we get the observed range, 5 to 60? You have to go back to the question. And you can see here, the smallest value of x is 5, and the biggest value of x is 60. So 5 to 60. So that gives us what we call as the observed range, 5 to 60. Is there any question?
No.
All clear, is it?
Yeah.
Okay, good. No question, yeah. So this is the explanation of the value of x, range of values of x. So there are two techniques. I mentioned about the interpolation. I also mentioned extrapolation. Interpolation is when the value of x is within the observed range. Like just now, it's from 5 to 60, right? And we use x equals to 40. So it's interpolation. Extrapolation means we are predicting a value of y of which the value of x is outside the observed range. So it could be bigger than 60, or it could be, well, less than 5. It cannot be negative, of course. Yeah. So we're talking about extrapolation if it's not within the value of 5 to 60. So make sure you understand interpolation within, extrapolation is outside. Any question?
No.
Yeah.
In the exam, when you answer, is the answer well very important. The final sentence thing.
Yeah. Especially when the question state to comment. Yeah. If the question asks you to comment, because if you look at this question, let me go back to the question here. There, it's too fast. Here you see comment on the accuracy of the estimate. So there is marks allocated for this, normally about 2 to 3 marks lah. It's not so much, but the tendency of the examiner to ask about giving comments, yeah, because we want students to be able to understand why you did the prediction, and also the value of the independent variable, what kind of effect of the result obtained, in the dependent variable, whether it is reliable or is it accurate or not. That is what we focus on, especially the accuracy lah. So I'm sharing here. Let me show it to you, the answer again. That this is the recommended way of writing. You can use your own words to explain as well. But the ones that I highlighted in green are the keywords that I will be looking for. Yeah, of course, stating the value of x and what is the observed range is also important.
Is interpretation and comment is the same thing?
Interpretation, yeah, almost the same. Comment. Sometimes the examiner, they use the word interpretation, they use comment. Yeah, it's the same. Yeah. Okay. Is it clear? Do you understand? Any
Yeah.
other question? Okay, so that's good. So okay, yeah, I already explained that, Kan. So next we look at the advantages and disadvantage of the methods that we learned just now. The good thing about doing regression analysis is we are able to estimate the line of best fit using the available data. And because we already created a mathematical equation, yeah, the equation is y, excuse me, yeah, a bit of cough. Where did I go yesterday? I didn't go anywhere yesterday. Oh, I did. I went to ITCC. I went to get some buns, Subway buns. But I didn't meet anybody much. But there was this one lady, she was trying to get too close to me. I got so scared yesterday. Phobia already to go out. I'm just writing the formula, yeah, because we already know the value of A and the value of B. So we are able to estimate the line of best fit. Now it says line of best fit. That means I can put two values of X, yeah. I can choose, remember the example just now, the smallest is 5 and the biggest is 60. So I can put these two values into the equation, and the 2 points, I would be able to create two coordinates and then join them as a straight line. So that would create a line of best fit. So imagine that, class, yeah? If you already identify the line of best fit, and then apparently you draw it on a graph paper, say this is your graph paper, you would be able to estimate for any values that you want to predict. So for instance, I want to predict a value here. Maybe this is x equals to, 28, for example. Then I can just reach until I reach the line, and then that would give me what is the estimated value. So we can estimate. It's very easy for us once we get the line, the equation, because you put two values of x. Yeah, you can form a line, connect the 2 points, and we can do a prediction. And that is what most businessmen wants. They are able to predict, okay, if this is how old the machine is, what are the maintenance costs that they have to incur? Okay, so that's one advantage. It is more reliable estimate than any other technique, which, of course, if you already have the equation, it's proven by a statistical calculation. And if you want to convince your investor, it's reliable because you have the mathematical equation to support your suggestion. Yeah, so that's why we say it's more reliable. And the reliability of the estimate of this equation, that means, can be proven by using the R, by calculating the correlation coefficient. This is what we're going to do next. Yeah. And of course, you'll see that the mathematical equation, the y equals to a plus bx, has a very strong connection to the R, the correlation coefficient. Okay. Now the disadvantages for this method, it assumes a linear relationship between the two variables. But as we all know, in the real life, it's not the case. Nothing is linear. There's definitely some impossible. It's a perfect line, straight line. So basically, it's not it's not linear, but we make that assumption, which is considered as a disadvantage. And not only that, it assumes past data as a reliable guide for the future, but it's not always the case in real life. Yeah, because past data, for instance, well, of course, I can take one example like 20 years ago, um, that is considered past data. Smartphone had not existed yet 20 years ago. So we cannot use what happened 20 years ago to predict the future. Yeah, you cannot expect 10 years ago to be used as a prediction for the future. So something that is more than 10 years is not reliable anymore. Yeah, because time change. Yeah, like what happened in 19, no, what happened in 2019? You cannot use the data 2019 to predict 2022. Why? Because of the pandemic, everything changes. Even education is affected. In fact, everything, ceremony, hotel, tourism, a lot, especially education is affected. Um, what else? Yeah, affected. Every area, I think, is affected. Is there any area that is not affected by the COVID? Can you
Food
think?
Panda.
Oh, that's a good idea. Yes, Food Panda is affected in a positive way. We're not saying it's not affected. It is affected, but it's affected in a positive way. Some are affected negatively, but Food Panda, food delivery, online shopping are affected positively. Yeah. So what you use as the past data, even as recent as 2019, we cannot assume it as reliable in 2021, 2022, especially 2022. Yeah. We cannot use that as a reliable source of information of the past data. Yeah, I was talking to my family just now, earlier. Um, she works at Gleneagles in KL, and she was telling me that even though you are vaccinated, you can still get infected, isn't it? So this disease is going to stay. It's going to affect our travel. I mean, like now, if you want to travel, it's very costly because before you travel, I don't know, if we want to leave Malaysia, do we have to get swab? Definitely. And when you reach to a destination, well, you already got that result. And if you want to go to another destination, you need to get another swab to enter that country. So can you imagine that? Traveling becomes more expensive. And if last time a person can travel to 80 countries in 1 year, now it's so difficult. You can if you are very rich. You have no financial problem. So yeah. So again, that's considered as a disadvantage. We cannot use the past data before COVID because it's not reliable for us to predict for the future. Everything changes. Yeah. And of course, here, as you know, because when we're doing this regression analysis, we only have two variables. We assume that the dependent variable y, yeah, it depends entirely on the value of x, the independent variable. But of course, as you know, it could be due to other factors. Like, let's say I talk about age, which is independent variable, and blood pressure. Blood pressure is dependent variable of your age. The older you get, the more chances you get blood pressure. That is a research medically, um, proven. However, there are other factors that cause blood pressure. It's not only age. It could be caused by you exercise or not, the food that you eat, the stress level that you have. So all those are also considered as a contributing factor to the blood pressure level, not only on age. So because of that, when we're doing regression analysis, we assume that there is only two variables and only the variable x is the indicator to y to y. Why is it y like that? Yeah. So which is again a disadvantage because one particular variable, it's not caused by just one factor. It could be caused by many other factors. So again, it's a disadvantage. Yeah. But sometimes when we do this kind of analysis, when we create the mathematical equation, um, that's why it's not business people, they use it as a guideline only. Yeah, like investors, people who has to make the decision, they use this mathematical equation, the y equals to a plus bx, as a guideline only. It's not like 100% decision because there are other constraints that they have to think of. Yeah. So I think that's all I want to cover. But there is an example here which I would like you to try. Yeah. So you see, I don't know, is the answer available in your notes? Hello.
Example 4.
Hmm?
Wait, don't have. Only,
Oh, yeah.
only
The answer available?
no, just a question.
Ah. So you see here, I want you to try out, yeah, to use the method of least square and to estimate the sales for 2001. So you see, this is a data. Let me get my pen. And this is 1996, 97. You know that 2001 is somewhere here. So basically, this is your X and this is your Y because the year you cannot control. But instead of using 1996, 1997, 1998, it's very big number to calculate, isn't it? So what I want you to do, oops, I'm always like this. I want you to do this. Yeah. Well, I'm sharing you the answer. Notice that I'm using 0 for X for 1996. So you can see that when you start 0, 1, 2, 3, 4, yeah, I get my answer and you calculate it, I get this value. So this is the regression line. But what I want you to do, class, instead of using 0, 1, 2, 3, and when I want to predict, hang on, for X for 2001, because 2001 is supposed to be here. Let me get a better ink because that one is not clear. I want you to do something, yeah? So if I want to predict 2001, because in my example, I use 0, 1, 2, 3, 4. So that means 2001 is equal to 5. Yes or not? So you see all the calculation here, all these values available here. So I get this equation as my regression line. Now, what I want you to do, instead of using this, I want you to use the X, starting with 1, 2, 3, 4, and 5, and calculate the whole set. Can you do that? I want you to check Is your B still the same? Is your A still the same? Can you do that now, please, class? Okay, I give you about 10 minutes to calculate that. I hope that is enough. Then I want to ask you later. Okay?
What?
Okay.
Kelvin. Because now the answer is already provided, kan? The whole answer is provided. But what I want you to do now is, because with 0, 1, 2, 3, 4 as your x to replace all the 1996, so to predict 2001 is 5. But instead of using 0, 1, 2, 3, 4, I want you to do the whole table again, but using the x as 1996 equals to 1, 1997 equals to 2, and 1998, and so forth. Lah. Instead of using 0, 1, 2, 3 until 4, I want you to use 1 to 5. Is that clear?
Oh,
Okay.
the
Can you
the
calculate? Yeah. Can you?
final answer should be the same, right?
Why? Why do you say that? Is the B the same as this, and the A, is it the same as this?
I think so. I mean,
Can you verify it for me? But your think so is correct. But check it out. Mhm. You get different, is it, Noel? Isn't it supposed to be the same? Oh. And you use x equals to 1, 2, 3, 4, 5, is it? Your y don't change, huh? Your y is still the same. So that means here would be 103. So you multiply like 2 times 167. Can you double check why you don't get the same answer? Because it should be the same. So that means all this would be different value. X squared would be different also because you get 1, 4, 9, 25. Sorry, that should be 16, right? I haven't calculated it though.
They're all the same answer.
The same, isn't it? Should be the same. So this one should be
Um,
16.
I'll make a small mistake earlier.
Oh, you made a was it you, Calvin, or was it Noel?
On Noel.
Do not include the 2001, Farah. Sorry about that. I didn't see your question earlier. I mean, the 2001 is the prediction. So here, 2001 should be 6 lah, because we want to do the prediction. So 2001 would be 6 if I'm using, why cannot erase already? If I'm using this x equals to 1, 2, 3, 4, 5 instead of 0. Yeah, so our 2001 would be 6 lah. Your total of x is 15. That is correct. Yeah, that is correct, Noel. It should be 15. All 10 change to 15. Yeah, correct. And of course, your y no change. Your xy, the xy needs to recalculate. Your summation of xy is 3, 6, 7, 2. Is it correct, this one, Calvin? Okay, good. And then your total of x squared would be, what is your total of x squared?
55.
Huh?
55.
Oh, 55. Yeah, you did write it there. So it should be 55. So when you put it into the formula, it should be the same as 50.7 and 109.6. Can you recalculate that?
What? What? Calculate what?
The B and the A. Then it looks correct. Eh? Yeah. Yes, Noel. How about this one? 105. Correct one? Same.
Oh, the A. The A. The A. I think the formula.
The formula?
Oh, we didn't get the 109.6.
What did you get?
The Noel 58.9.
The A, you get 50.
58.9.
The B, did you get 50.7?
Oh, yeah.
You get 50.7. So this is not 10, yeah? It should be 15. How could you get 50.7? Hang on. Hey, yeah, something is missing here. Summation of y is correct. Because this one is still the same. Should be the same class. Hang on. Summation of x bar. Yeah, correct class. Summation of x times divided by n. That would definitely affect a lot. It becomes very messy already. Yeah. This one correct already. I've already written that. 1 plus 2, 3, 15. Correct 15. This one no change. Summation of xy. 3672. You got the 50.7, yeah?
Yeah.
Okay. Then we put it here. The only thing is here will become 50. Summation of y. Yeah, I got 58.9. Then it will be entirely a different value. It should be the same. There's something missing here, class. I cannot figure it out. Did I calculate the y correctly? I mean, the total for the y, is it correct? Summation of xy. Because the 50.7 is correct. Then the formula for a is summation y divided by 5 minus with 50.7, which is the b, summation x divided by n. But the question in your notes, does it tell you? Hang on now. Let me discard all that. I want to see the notes. Chapter 7. Does it say in the question to use the formula? I mean, to use x equals to 0. Uh-huh. Okay, class. We are to use x equals to 0. So 1997, use, is this the question, yeah? So 1997, use 1 lah. If that's the case, no lah, don't do that. Because I ever ask students to do this, and then I ask them to use the value of 1, And they say it's the same. It's a bit odd. Therefore, use this one like class. So remember, you cannot change it as x equals to 1 for 1996 equals to 1. Yeah, the y-intercept would also definitely change. Yeah, good assumption, Noel. That is true. Yeah, because when I checked the question just now, I'm answering correctly that the x start with 1996, we start with 0. Yeah, so this is correct. So if you go and change x equals to 1 for 1996, it would definitely give us a different value of the where it intercept the y-axis.
You can still estimate 2001 the same answer.
The estimate, when you put the values, is it the same?
If you put if
The
you
58
if you put 58.9 plus 50.7
and
times 6, and then
yeah,
you still get the same answer.
the estimate is still the same. It's just that the formula would be different when we
Yeah.
use x equals to 1, 2, 3, and so forth. Okay, so yeah, that's very good. Yeah, so I hope you are clear, because I don't know whether I have another slide that discuss on that or none. So that one I will discuss much later in the discussion of what is A and what is B. Yeah, that would be another different area when we finish the topic basically. So yeah, so that's it. Any question about this? Oh yeah, don't forget to do the estimate. I haven't touched on that. 2001, we're using x equals to 5 for 2001. And when you put it into the formula, you get 363,100 ringgit Malaysia as the value of estimated lah for the sales for 2001. Okay, yeah, good observation, Noel. All right, so okay, for tomorrow, I think I'll stop here. Any other question from anyone?
So the x must start from 0 lah, kan?
Yeah, because remember the question I showed to you just now, this one. You can see this is the question. It's stated here. Well, it's stated in the solution already to use x equals to 1996. So
So
we
if
do.
like other question,
Mhm.
so start from 0 as well.
The question start from 0. No, if you are answering other question, it doesn't really matter actually. Um, like here, I follow based on the solution, it's 0. But if you use x equals to starting from 1, yeah, you use x equals starting from 1, it would still give you the correct estimation. It's just that your formula may look different, but when you put the value in, it will still give you the same answer here. Because of course your x, when we want to estimate for 2001, when you use x equals to 1 here, 2, 3, 4, 5, therefore 2001, you'll use 6 here. Because different value, isn't it? So the estimation is still correct.
Oh,
Yeah,
so I have to read the solution before lah, kan?
not solution, read the question. In this example, yeah, the
Oh.
question, what is the value of x? But actually in the exam, if let's say you use 1, 2, 3, 4, 5, or if you use 0, 1, 2, 3, 4, 5, either way, it still gives me the estimation is still correct. Yeah. Is that clear, Noel?
Oh, yeah.
Okay. All right. So what is it I wanted to say just now? Yeah. For tomorrow, what I want you to do is that you have tutorial 9, only one question, question 2, because we only cover up to here. So do question 2. That's what we're going to do. And the rest of the time, I'm going to issue you your assignment. You have to start your assignment already. Okay?
Okay.
So we'll discuss question 2 tomorrow, and I start issuing the assignment. And of course, the assignment, it's not limited time. You have plenty of time to do. You'll be able to submit after a few days. All right?
Okay.
Any question on that?
Is there a due date for the assignment?
Yes, of course. About 3 days like that. Do you have a lot of other assignments? Or you all already passed
So
up?
long.
Still have assignment, is it?
One more.
When is it due?
Week 13.
Huh?
Week 13.
Lama lagi tu. Why not submit my work first? But I give you time, don't worry. We'll discuss about the due date tomorrow. Okay, so do this question number 2 on tutorial 9. So I'll see you guys tomorrow. Bye.
Thanks.
Thank you.